So one of the last sets, maybe the last set of actual new formulas in chapter 9, 9.3, we are only going to be focusing on the double angle formulas. So we will not have time to work on the half angle formulas. They're not used as often, so I'm not worried about those. So the first thing we need to do is copy down the formulas. So here are our formulas for the sine of 2 theta. It would be 2 sine of theta cosine of theta. The cosine of 2 theta has 3 options, and that comes from the fact that the relationship between sine squared plus cosine squared is equal to 1. We can take the original formula and make it only sines or only cosines. So this is the original. These ones have just been transformed based upon our identities. And then for the tangent, yes, that is our option. You'll notice if you look at the sine or the tangent sum formula, it's very much related to that. But remember, you could also do the sine of 2 theta divided by the cosine of 2 theta. So no matter what your angle is inside here, you can relate it back to sine and cosine as well. You would just have to use the formulas you saw up at the top. So those are our last chapter 9 formulas. Remember, for all of our sections except for 9.1, the formulas will always be up to the board on your left. So you will have those for any quiz or test we take over this stuff. The only formulas you have to know are your 9.1 identities. So you need to know those 9.1 identities. You need to also know your unit circle. So make sure every so often you take a look at that colored sheet we did together or your unit circle. As soon as you are done with these formulas, take a screenshot so that you have them in your camera roll, and that's another set of formulas that you will need to use. These ones come up in calculus here and there, so those are, of all the formulas up on the board, I see those most often in a calculus class besides just the general identities. Okay, so hopefully everybody has those written down. And now let's do some examples with it. So it says, given that we have a tangent of -3/4 in quadrant 2, find the following information. Find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. Now this is going to come back and combine some information that we learned in chapter 8 and also our SOHCAHTOA information from chapter 7. So this problem actually is a combination of many things. Here is the strategy that you should take when you do these problems. First thing we should do is we should draw a picture, and in quadrant 2 we should draw a triangle with theta next to the origin. So just like we had done in earlier sections. Okay. Now it says that our tangent is -3/4. What I would also do is I would put the fact that this is going to the left, so it is negative. This is going up, so it is positive. Remember, our hypotenuse is always positive. The only ones that might have a plus or minus sign will be the legs of your right triangle. Now, based upon what we know about the tangent, we know that the tangent is opposite over adjacent. So we would need to make the opposite 3 the top of our fraction. And then the 4 would be the one that gets the negative on it to make a tangent that corresponds with what we were given. Okay. Now, what you're going to do every time before you proceed to the next step is you're going to write on the side of your paper somewhere the sine of theta equals, the cosine of theta equals, and the tangent of theta equals. So we're just going to do SOHCAHTOA for the sine, the cosine, and the tangent. Now we've already been given this one, so just fill that one in. And let's think about, nothing old or nothing brand new. Let's think about from chapter 7 and 8, how we would proceed to find the sine and the cosine. To proceed to find the sine and the cosine, we would need to find our hypotenuse, which usually is labeled with an R. So we know that 3 squared plus -4 squared has to equal R squared. So R squared is 25. R would be the square root of that, or 5. Now we don't do the plus or minus for our hypotenuse. The legs might have a plus or minus on there. So for the hypotenuse, always make it a positive. Once you have found that information out, or whatever missing side you needed to find, make sure you have all 3 sides. Think about back in the day. Let's label this as our opposite. This is our adjacent. This is our hypotenuse. And then let's fill in the pieces that we don't know. The sine of theta is opposite over hypotenuse, or 3/5. The cosine of theta is adjacent over hypotenuse, or -4/5. And a way that you could check your work is if I did big C over little c, sine over cosine, it would give me the tangent. Sine over cosine should give me a tangent. So that's a good way to check your work. Now you have to do that first before we can answer the questions below. Because if you look on the board on the left of the formulas that we wrote down, you'll notice that the formulas, let's just look at the sine of 2 theta formula. The sine of 2 theta formula basically says that the sine of 2 theta is 2 sine of theta cosine of theta. So you'll notice that the formula utilizes theta, so we need to look in our triangle and find that information about theta. So that's why we have to have these in order to fill in the formula. So let's take a look at our first one here. The sine of 2 theta is 2 sine of theta times cosine of theta. So that's going to be 2 times the sine value we found, which was 3/5, times the cosine value we found up above, which is -4/5. Now, the sine and the cosine are both some number between +1 and -1. So make sure if you get an improper fraction, you know you're wrong. So we should be shooting for a proper fraction. To multiply fractions, any whole numbers, put them over 1. Multiply all of the tops. 2 times 3 is 6, times -4 is -24. 1 times 5 is 25. You will notice it's a proper fraction that happens to be negative because the top value of 24 is less than the bottom value of 25. That's a really good check that, yeah, we were on the right track. Okay, so that's our first one there. The next one that we want to do is our cosine of 2 theta. Now there are 3 formulas on the board for the cosine. It does not matter which one we use. And I'm going to show you. I'll do the formula a few times to make sure that you notice that. But let's write down the first one, that the cosine of 2 theta is cosine squared theta minus sine squared theta. And let's do it the first way, and then we'll try it again 2 different ways. Our cosine, we have to square it. Our sine, we have to square it. Cosine, when we square it, that we are squaring -4/5 from above. Sine, when we square it, we're squaring 3/5. Remember, when you square a fraction, we're just going to square the top and square the bottom. So if we square -4 over 5, it becomes a positive. That is 16/5. When we square 3/5, we get 9/5. And it better be either a positive or negative proper fraction. 16 minus 9. Oh, I'm sorry, that's 25th. I found my mistake because I was going to get an improper fraction. So that's a good way to check, hey, something's wrong. So anyway, to square fractions, square the top and the bottom. I forgot the bottom. 4 squared is 16 over 5 squared, 25. Anyway, we have common denominators of 25. So keep that 25 and subtract the tops. 16 minus 9 is 7, which is indeed a proper fraction. Now, you could have used that formula or any of the others for cosine. So let's do it one more time just to prove to you. We don't have to do it twice. We found it. But let's go ahead and let's use one of the other ones. I'll just go down the list. The next formula listed is 1 minus 2 sine squared theta. So let's just do it again so I can prove to you it does work. Okay. So if we decided to use that formula, that's going to be 1 minus 2 times our sine value squared. Our sine value was 3/5. So let's do the math. First, let's square that fraction. To square a fraction, square the top and the bottom. To multiply by a whole number, put it over 1. I'm going to do the back here to illustrate what's going to happen next. That's going to be minus 18 over 25. Now, 1 whole is 25 over 25. So that's how you could get common denominators. And then just subtract. 25 minus 18 is indeed 7 over 25. So it doesn't matter which one of those formulas you decide to pick. If I already went to the trouble to find both the sine and the cosine of the original, I just usually use the first one I see. But if you only had to find the sine or the cosine from above, you can use the appropriate one that uses the information you have. Okay, any questions there? Are we good with those?
For tangent, aren't there technically two?
Yeah.
Are those two?
Yeah. Yeah. So now let's do the tangent. We'll do both formulas that we've got, okay? So tangent, let's do the weird one. And because they've already asked us to find the sine and the cosine, we'll do the nicer one. Okay, I want to show you that both will result in the same thing. Okay, so the tangent of 2 theta, the more complicated one is 2 tangent of theta over 1 minus the tangent squared of theta. Okay, so let's use the more complicated one, and then I'll show you what we could do with the information we found in A and B. Okay, so let's go back and look at what we know. The tangent is negative 3/4. Let's put that in. Now, the reason I like to use the less complicated one, which we'll do next, is because I see that and I know how you guys tend to ruin fractions. And so that's why I think this formula can cause issues, because you can ruin the fractions pretty easily.
You're never going to let that down.
No, I'm not. So let's take a look. Well, maybe I'll see improvement, which will be great. Okay, so anyway, let's take a look at our top. To multiply the negative 3/4 times the 2, it'd be 2 over 1. So we would get negative 6 over 4, which can reduce because 2 and 4 are both divisible by 2. So we can make that a 1 and a 2. And so if we do that on top, we get negative 3/2. Okay. On top, we get negative 3 over 2. Now, let's take a look at the bottom. This, to square that fraction, we would make it the square of the top, square of the bottom. That's 9/16. So 16/16 minus 9/16 is 7/16. And then you can do big C over little c. Big C goes on top, little c goes on the bottom, big C over little c. The big C, I'm just going to kind of show you what happens. We get negative 3 times 16. On the bottom, we get 2 times 7. Now, the reason I wrote it like that is because you are allowed to reduce tops and bottoms. 2 and 16 are both divisible by 2, making that a 1 and an 8. So we get negative 24 over 7. Now, tangents can be any number from negative infinity to positive infinity. So the proper fraction thing isn't something we need to check. It should just, you'll get a fraction. It could be proper, maybe not. Okay. Now let's go back and do the tangent of 2 theta formula using the information we found earlier, the sine of 2 theta over the cosine of 2 theta. Okay. We found that the sine of 2 theta was negative 24 over 25. We found the cosine was 7 over 25. So we can do big C over little c, and we better get this answer right here. Now look what happens. We do big C over little c. On top, let's just write what's there. We have the big C is 24, negative 24 times 25. On the bottom, the little c is 25 times 7. And you can see that the 25s cancel. Oh my goodness, we get negative 24 over 7. So you have more than one way to get that answer. Just like our cosine, we have a few alternatives. If you already found the sine and the cosine earlier, why not use it to make a tangent? So I would probably not use this formula. If I were doing this problem, I would probably do this, since they already made me find sine and cosine anyway. Okay, so that is the main type of problem I want you to get out of this lesson. So if you can do that, and if that made sense and you were able to understand those formulas, you got it. That's the main thing, okay? Are there any questions about number 1 before we move on? Take a look, make sure you're good to go before we move on. Okay, so now if you could look at example 2. So it says use the double angle formula for cosine to write the cosine of 6x in terms of the cosine of 3x. So what you made, the major takeaway is that this is double that. So let's write down our formula. The cosine of 2 theta. And we're going to use the formula that only contains cosines because they only mentioned we wanted cosines. So we're going to use the one that says 2 cosine squared of theta minus 1. Okay. Now, the cosine of 6x is the same, what you want to think about, as the cosine of 2 times 3x. So the 3x is our theta. See how that worked? So if I break up 6x to be 2 times 3x, we can more clearly see what our theta is. Our theta is whatever's sitting by the 2. And so now we just plop that theta, that 3x, into our formula. We're done. So that's 2 times the cosine squared of 3x minus 1. We have now written what was the cosine of 6x in terms of 3x. And that will become helpful when we do 9-5. There are some times where we can do a little rewrite and it will make the equations we're going to be solving in a 9-5 flow a little nicer. So that's why I wanted you to see one like that. I don't think there's any like that in the homework, but I wanted you to see that tactic now. So when we get to 9-5, we just have some other options to work with. Okay. And then our last example is a verification. So we have 1 plus the sine of 2 theta equals the sine of theta plus the cosine of theta, that quantity squared. Now, you might recognize that looks a heck of a lot like one of the identities that was on the quiz. One of the ones I said, oh, that's kind of the hardest one, okay? So I am going to show you how to solve this. Now, just because I've been doing identities for a long time now, I can see how both directions is, there's a way to go both directions with this one. But I am going to make this my answer. I'm going to hold that as my answer. And I'm going to prove to you that this is equal to 1 plus the sine of 2 theta. So when you see this, what we have to work with is the fact that the sine of theta plus the cosine of theta squared is really the sine of theta plus the cosine of theta. Because I'm going to FOIL it, okay? So let's FOIL it out. When we FOIL it, remember, we're going to do sine times both, then we're going to use cosine times both. So we're going to get 4 multiplications. So let's go ahead and multiply that out. We get sine squared of theta plus sine cosine plus cosine sine plus cosine squared theta. Now, what do we have to work with? Well, at this point, let's talk about these things right here. This is almost like saying x times y and y times x. They are like terms. Multiplication's order doesn't matter. 2 times 3 is the same as 3 times 2. Sine times cosine is the same as cosine times sine. So I have one of these plus one of these. I have a total of 2 of those things. Now I'm going to write the sine squared and the cosine squared together. Now the reason I'm going to write that together is, everybody, what does sine squared plus cosine squared equal? 1. And so the trick we're going to use is we're going to replace this with 1. We needed a 1 to appear in our problem anyway. Because remember, we know ahead of time what the answer is. So keep glancing back at that answer. Anybody notice something that has appeared? What is the sine of 2 theta equal to? 2 sine of theta cosine of theta. So this is equivalent to that. So based upon that, we can use direct substitution. The sine of 2 theta is the 2 sine of theta cosine of theta. So let's put that and rewrite that as the sine of 2 theta. And we are done. Okay, so that's just kind of an identity that goes with these types of problems. We can substitute sine of 2 theta for the formula, or vice versa. If we can go backwards and forwards. That is a fact, that the sine of 2 theta will always equal 2 times the sine of theta cosine theta, so we can substitute that in. Okay, so now we've got that. I need you to look at your homework. I've made some changes, okay? I want you to do the first one that was there. Skip everything else and add these 2 new ones on, please. So at this time, for your 9-3 homework, keep the first one, scratch out 2, 3, and 4, and add these 2 and 3 here. So this one says, if the cosine of x is 2/3 in quadrant 4, find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. So problem 1 and the new problem 2 are like the first example we did together. You're going to draw that triangle. Problem 3 is like the last example that we just did. It's a verification one. We have lots of different formulas that we can use, so feel free to use any of those formulas. And so for the rest of class, please work on the 9-2 and 9-3 homeworks. And if you're stuck, I can work on some of those with you. The 9-2 and the 9-3 homeworks are due Sunday. Your Alex is due Sunday. So please, use your class time wisely. And there you go.